And you might be wondering why. Well, it's because I was too lazy to rewrite that and call it statistics. I suppose I could do that right now. Oh, I'm not going to. I'm too lazy. Just a minute. I'm still figuring out why this is not showing the screen. Hold on a second. Okay, now it's showing it. Just for the people at home who are watching, I'm sure. Anytime you're absent, you probably watch the video 2 or 3 times, don't you? I hope. Hopefully. That's why my YouTube analytics always says like 1 view or half of a view. It's always depressing. I never look at that. Anyway, getting back to this. So some of you have already seen this and you don't care. But actually you do care because I had to make midterm grades. They're kind of antiquated, aren't they? In the sense that you have midterm grades at your fingers anytime you want them. You could look on Moodle and see what your grades are. And I keep my grades up to date on Moodle, relatively so. But the college makes me do midterm grades, so here it is. So your midterm grades, you'll get them tomorrow or the next day. You might not even know. Whatever. But if you happen to look at them and you see your statistics, just replace calculus with statistics up here. Your statistics grade, and you might have some questions for me. One of the questions that I get asked quite frequently is, I just got my midterm grade. Why is my grade so high? And so I want to reassure you that if your grade is too high, I can help you to correct that. For example, you might have completed all your homework. You can check the grade report on Moodle to see if that's the case. I did copy all the grades over from Newton to Moodle last week, and so it's relatively up to date right now. Make sure that I have all the grades correct for your tests, because I might make a mistake, like this student here. It says that they have 95, but I might have accidentally typed it in as a 59. If that's the case, I make mistakes every now and then. Make sure I've got the right grades for you. Check for perfect homework scores. That might be a good reason why because it snowballs, doesn't it? You do your homework, it makes you understand the material better, and you end up doing better on the quizzes, and then you end up doing better on the test. So anyway, hopefully I'll give you some hints as to how to lower your grade. Not in Lumen, we use Newton in here, but just ignore this word here. You can always lower your grade by not completing your assignments. So if you want to make it lower, you can do that. Also, you could bomb an exam or two, and that'll lower your grade. Now, of course, I'm in jest here a little bit. In reality, the question that I get asked more frequently is this one. I just got my midterm grade. Why is my grade so low? Well, I bet you can guess what the answer is here. It's the opposite of the other one. First of all, you probably failed to complete a bunch of homework. You could check your grade report on Moodle. Make sure I have the right grades, that sort of thing. So check the grades for your exam, because just as easily as I could have given this person a 59 on their, in Moodle, this person has a 100, and I could have entered it as 001 instead of 100. That would be a shame, wouldn't it? But anyway, I might have transposed some digits. So anyway, I might have made mistakes, so please do keep me honest, if you will. Also check for zeros under homework. Well, really, you're going to look on Newton and look for the homework grades there. And if you have a bunch of zeros, then you need to fix those. Let's see, what else do we have here? You can complete homework late for a discount. Please do this, because even if you get 1 point on a homework assignment, like if it's a 90% discount and you get 1 out of 10 or something, it's still better than a 0. It's going to help your grade out. And then make sure you take studying for exams seriously. Use the study guide and come to visit me in my office at 6:30. Anytime, really, but 6:30 is best for me. Also, form study groups. If you've been doing poorly on the exams, work with some friends. Make friends with someone. Like go, peek at their exams and look for that person, like this person who got the 97 or this person who got the 100. Go find those people and study with them. You might even make special friends with someone and then end up married to them for how many years? 33 years? That's what happened to me with physics and what else were we taking? We were taking physics, drawing, and education, foundations of education, first semester. So I don't know what, something happened. But we ended up studying together, and here we are, however many years later. So, yeah, pro tip, Okay, is that it? That's it. So as always, if you have complaints about your personal exam, please do see me afterwards. I will stop the recording after class so that you can come and talk about your special issues that you're having. Let me just change gears here really quick from this calculus thing to something that's more statistical. Which one do I want? Which one? How about that one? Yeah, that one looks good. Central limit theorem. Yay! Okay, we're going to talk about central limit theorem today. The central limit theorem is the most important theorem in all of statistics. It is why statistics works. Now, for us, what we care about central limit theorem is a little bit different from what the statisticians care about it, but all you have to know is that this is why statistics works. This is all that, I mean, it's really the reason statistics works. So let me try to explain. Well, no, we'll do an activity. I gave you dice. Let's make lots of noise with the dice. Not yet, hold on. Okay, so, whoops, I just made noise. Okay, so here's the central limit theorem first, and then all this gobbledygook will make more sense if we do the activity. So, but let me explain it really quick first. It says that if you have a distribution of sample means, it tends to follow a normal distribution no matter what the distribution of the original population is. Ooh, a lot of gobbledygook there, right? What does that even mean? N is required to be large enough, whatever that means. I don't like this sort of, all this math. So let's do this, let's do an activity. So what I'd like you to do is, and I'll explain first, okay? Well, maybe I won't explain, I'll just show. But you're gonna, this is the central limit theorem activity. I probably should have put a link on our Moodle page for this, but I guess this is what we got here. Can I just click on this? How do I get this? Just a minute. Maybe I have to do this. I'm gonna actually do it on my own phone. So so there's this QR code. Will it work at an angle? Does it even work? Does it work? It works for you. Let me just see. Oh, look, it works for me too. I'm so happy. Okay, so that QR code will take you to a dice distribution activity page. And basically, I needed to remember how many times. Okay, you're going to roll the die. Hold on a sec before you start making noise. You're going to roll the die a total of 41 times. So it's a lot. But here's what I'd suggest, okay, is the first one is easy. You can do this yourself, like this. Oh, I got a 5, so I'm going to type 5 in. The second one, you probably could do yourself, but the third one, you probably would want to use a friend. And here's what I mean by that is here's let me just demonstrate this. Give me a sec. Hold on. Team up with someone, pull up an Excel spreadsheet, and if someone here does not have their computer, find someone who does. So anyway, pull up an Excel spreadsheet, and then I'll put this QR code up in just a minute. But on your Excel spreadsheet, you're going to have one person roll, and the other person, wait, where's my mouse? It's like I'm an elderly person here. Okay, there it is. Have one person roll, and the other person record the data. So hold on a sec, go back to the top corner. And so as I roll, I'll call out like 1, 3, 2, 6, 4, 1, 5. So that way it'll go much quicker. And then when you get done, then you trade places because I really need everyone to have an entire set of 30. So anyway, when I get done with the 30, I'll be down here. I'll just do the average of all of these, and that'll be my answer that I type into the Moodle page, or not the Moodle, the Google form. So anyway, let's make some noise. If it's, I sometimes have difficulty with noises. So if you're having difficulty with noises, you could always go to the hallway, or there's a little kitchenette back there if you need to be more private. Oh yeah, headphones works too. Yeah. So anyway, whatever you need, do the work, get it done. 5 minutes. You can do this. We can get it done in 5 minutes. I know you can.
pretty impressive right there. That was good.
Oh, you're gonna come complain now?
Well, I have to leave early, so I'm just gonna I sent it. I gotta leave early. Oh, is this one? In my mind, I put a number out of 200, so to me that.
Oh.
I get that you want a percentage, but like, is that a ratio?
Yeah, I just had to read 39 of what. Yeah, is there anything else you want to complain about? No.
Now that I'm working on this one.
There we go. I'll make a big thing here so that I can fix this. That should be in there. And I'll have to record it. And then if I get, either give it to you before you leave or just upload your dice deck. Did you do it already? Yes. Was that your first roll? Or your last roll? You did your third?
I like dice.
Nice. There's 22 ready. $32. 25. 26. They're rolling in. So exciting. 27. We need to get like a neoprene to roll on.
We need a lot of these and
Well, I have the baggie. That one is particularly expensive. Do I need to start collecting these now?
if you don't want to roll it, yes.
You can trust the rest of them. I can probably trust these. See, are we there yet? 29. 3 people. All right, stragglers, 3 of you. I know 3 of you are still working. I see the number. Response is 29. Maybe? I'll give you, 30, 2 to go. Whoever's straggling, just go ahead, pump it in there. Okay, while you're doing that, I'll figure out what I'm doing over here. So 31. Do I give up on the 32nd person? Oh, you're. That's hilarious. He's still working. Everyone's looking now. Yeah, if you're watching from home, Kieran is working feverishly to try to get his work. You got it done? Oh, 32! Yes! Okay, so all of these words, you can't see it, just a minute. There we go. What is going on? Hold on a minute. There we go. Okay, so all this says is that if you have a bunch of averages, I'll show you your data in a minute, don't worry. If you have a bunch of averages, you can predict with pretty good large amount of surety, you can predict what those averages are going to look like. Even though everyone had a bunch of random rolls of the dice, and I cheated. I actually had 9 dice up here that I just rolled them all, and it's like, I'm not going to roll this 30 times. I'll roll the 9, I did it 3 times, and I rolled 3 extra dice. But anyway, everyone's rolling 30 times, and everyone gets different numbers, but the averages tend to get closer together the more times we roll. Let me show you. That's all the central limit theorem says. And it says that this roll, the averages get closer in a very predictable way. Here, I'll show you my numbers. My first roll was a 5. I know you can't remember maybe, but your first roll, do you remember what your first roll was? Who else had a 5? Do you remember? There are a few people. Only a few? Okay, maybe you can't remember. I'll show you the data. I'll show you the data in just a minute. But anyway, mine was a 5, and then I rolled, that's my 10. So there's my 10 here. I'll show you my average here in a minute. And then here's my 30. Let me go to the bottom, and you can see my averages. Is the mouse up there? Yes, it is. So there's the average of 10. I had 3.2 for my 10. And then when I rolled it 30 times, I got 3.9. So I don't know if you remember what you got, but I suspect that not very many of you got 3.9 for your 30, and maybe a few of you got 3.2, just because, we're all different. We all have different averages. But the cool thing about the central limit theorem is that the averages tend to get closer and closer to one another in a very predictable way. So let's take a look at this here. Responses. And so check it out. This is the number. Okay, they have the percentage and the number. But everyone got different numbers for their first. Remember, you had to roll once. So there's the numbers there. Now we go down to the rolling the dice 10 times. What's the average? So back here, some people got 1, some people got 6. That's a range of 5. Everyone's spread out. So everyone gets something different. But we get down here to the average of 10. Oops, there it is. Wow, someone got a 4.7. Anyway, but notice that the averages get closer together. So we start off from 1 to 6, all the numbers. Now we start out at 2.6 is the lowest, 4.7 is the biggest. That's only a range of 2. Only 2 instead of 5. So you've got, 2.1. So people are getting closer together. And then we go down here to the 30. What in the world? That's so weird. Well, it doesn't matter. I've got some more obedient students, or maybe can follow instructions better, that I'll show you the data for in just a minute. But so here, it looks like we go from 2.933. I know what the problem is. This isn't a histogram. This is just a bar chart. Interesting. Well, it doesn't matter. I'll show you, because in reality, I do need to do this. I'm sorry. I can't let this stand. This is no good. Back up here, view in sheets. Give me a sec. Okay, so there they are. And this will just take a minute. Let's do this, insert. Let's insert a histogram. Can we do that? How do I do it in Sheets? I don't even know. I'm going to have to download this. But this is getting to be a nightmare. Save, download. Microsoft Excel. Whew. Sorry, I didn't realize it would be this painful to watch. Okay, let's open this up in Excel. What's going on here? There we go. Okay. Okay, let's try again. I want these data, and I'm going to insert a chart, and I want to insert a histogram. Let me find the histogram here. Histogram. Okay, oh, that is so beautiful. Oh, I love it. Oh, isn't that beautiful? Look at this. It's a nice bell curve, and it's centered right here, and people are spread out, but that's so beautiful. Let me check out that was for 10 rolls, and then averaging together. And then let's do the 30 roll one here. Do the same thing. Give me a sec. I'm going to insert a histogram. I have to do it this way because I don't know what to click otherwise. All charts, histogram. Okay, this one doesn't look quite as beautiful, but still. So you guys were good. You did a great job. Oh, that's so nice. Oh, that's so beautiful. I mean, this is roughly a normal curve. Okay, so like I said, there's only 32 of us in the room now, and so it's not really enough to get a good feel for what's going on here. And so what I did was I've simulated 1,000 students on this next Excel spreadsheet I'll show you, and they are so good. They don't mind rolling dice, and they do it silently. I mean, check this out. Here's my 1,000 students. I have them roll 5 times, and this is their chart. Let me do it again. I'll have them do it again. Ready? Boom. They just, all 1,000 of them rolled the die 5 times. They did their averages. Beautiful histogram, isn't it? Now let's have them up here at the top. I have some numbers where I can change. Let's have them roll 10 times. 1,000 students rolling 10 times each. Amazing, isn't it? Let's do this 25 times. So I could have them do 100 times. Let's do 100 times. Now here's what I want you to notice about this. That it was kind of hard to tell when we did it. I was kind of hoping for a little bit more obvious result when we did this together. But one of the things to notice about these 1,000 students is that their averages are getting closer together. They're getting lumped up in the middle here. Let me go back and have them roll the die 5 times again. 5 times. And they're all spread out. I mean, you've got someone over here. What are they doing over there? I don't even know. But this is all spread out. Whereas when you have them roll the die 30 times, let's just do 30, they're getting closer together. When you have them roll it 50 times, closer together still. Do you see how we're getting clotting sort of closer together? 75 times, and finally I can go up to 100 just because that's as far as I'm not going to push these guys any further than that. But that's 1,000 students rolling the die 100 times, averaging them together. Look at that. Now, the central limit theorem says that you're going to be able to predict exactly what this curve is going to look like. And so here's the way you do it is, let me see, do I have this up here? There it is. I'm going to put it up on the screen here. Central limit theorem for means. First of all, if you have however many, it doesn't matter how many people, well it does, if you have 1,000 students roll dice, the sampling distribution of means is normal. That's the first thing to note. And you kind of get a hint of this looking at this picture. Let me get, that one's harder to tell. Let's go back to 50 where it's spread out a little bit more. So you can kind of see the normal curve here. If I had 10,000 students, it would be even more obvious that this is a normal curve. In fact, if I have them roll, oh, isn't that one beautiful? I almost want to take just a minute. Is it be real time? I hope so. No, it's not. Well, I'll just take a picture anyway, just for my own. Such a beautiful picture. But anyway, sampling distribution is normal. That's what that says. That's the first thing simple limit theorem tells us. And then the mean does not change. What does that mean? I don't know, it means the average. The average does not change. I don't know if you noticed, but with the averages, let's hear. Let's go back to this one. This one? Sure. Okay, so this is you, all of you. And if we were to average together a single die, in fact, I'm going to do this. Give me a sec. I know it's hard to see all of this stuff, but we'll go to the bottom here, and we'll just do the average, the mean, equals the average, I need my glasses or something, just a sec.